let's try some example. These are all the formulas you need to know how to apply. Okay, let's try number 5. A planet of mass m moves around the sun with angular velocity omega. The distance between the centers of the sun and the planet is r. So what's the velocity of the planet?
Is it the angular velocity?
Just use the formula though. How is it related to r and omega?
2 by eh,
Yeah, given mass m, omega, and r. So how is velocity related to all these variable?
they didn't give the time though.
V equals to r omega.
Oh,
That's all. Memorize only.
oh yeah.
Okay, what's the acceleration? Memorize the formula only. Getting you to memorize the formula.
V square over R.
Right? R omega square. V is not given.
Oh yeah, yeah. Okay, okay.
Centripetal force.
Um,
Memory word only. Now recall. Mr omega square. What's the period?
2 by R over R omega.
2 pi over omega.
Eh
Number.
no.
Okay.
Yeah, 2 by over. Okay, yeah.
Number of revolution per second. That means they want the frequency lah.
Hmm.
In terms of omega. That's all.
Oh,
Can or not?
well, yeah, because some of the formula is like
That's why I want to review with you. If not, you forgot the formula, how to you don't know how to use the formula. Know how to play with the formula.
okay.
Okay, try this question. A body moving in a circular path covers 25 revolutions per minute. What is the angular velocity in radian per second? Change the revolution to radian. No?
Wait,
Can? Can or not?
isn't that the frequency?
Yeah, it's frequency. Yeah, right. Yeah, right. You want to change it to
So
angular frequency, angular velocity,
must I change it this minute to hour? Per minute to hour.
minute to second. Minute to
Oh,
second.
second. Not hour.
No, it's
Okay.
radian per second. You want radian per second. One revolution is 2 pi. Minute is 60 minute. 60. One minute is 60 second. No? Right? One revolution is 2 pi radian. So omega is 25 minute. You change second. No? 60 second times 2 pi. Right? Oh, that's how you write 25 revolution per second. Revolution, you change it to 2 pi radian. 1 minute, repeat as 60 seconds, so you got radian per second. No? Okay, 360 degree, how many radian?
360 degree.
360 degree, how many radian?
Uh, 3.142 times 2.
Just give a 2 pi radian, good enough lah, no need to calculate out. 180 degrees, how many radian?
180 is
Ah,
pi.
pi radian, no? 90 degrees.
90 is 1/2 pi.
Hmm. Try this one.
Can I have a look at the 6 again? Ah, okay, can already.
How about this one? Playing with the formula only. Start with v square over r.
Hmm.
Right? You want the one v, you want v, you want t and r. Right? Use v square over r. Place a v with 2 pi r over t. What's the answer? Can. Anything not clear?
Um, okay.
Okay, how about this one? An object of mass 45 grams attached to a rope is wheeled in a vertical circle for radius 50 cm with a uniform speed of 7.5 meter per second. What's the period of the object? From radius and speed, convert it to period. V is S over T, so period is T equals to S over V. No?
Oh, okay.
Yeah, can?
Yeah, can.
0.42 seconds. Acceleration on the object. Basically, I'm trying to force you to apply the formula, that's all. Memorize the formula, apply the formula.
No, it's not very straightforward.
It's very straightforward. Push in your
Yeah,
head, that's all. Force the formula into your head. That's all. That's all I'm trying to do. You keep on
okay.
using it, then it becomes part of you. Acceleration is v squared over r, that's all.
Yeah, true.
Ah,
Okay.
let's put in the formula and use calculator, calculate out. Tension in the rope at the highest point of the revolution.
Yeah. Sure, but wouldn't you get confused if you use T for tension and period at the same time?
I can get a bit confusing, but here the T is a tension, not period. That's why I call
Oh,
T1. The top there I call T1. T1 is the period.
oh, okay.
Can be confusing. Can. Remember your resultant force is centripetal force. And you have calculated the acceleration already. So you just use the Newton's second law. Fc is ma.
Okay.
Right? At the bottom, there's the forces acting mg count. Centripetal force is still upwards. Can? These are the things that's given. Can or not?
Yeah.
Okay, drawing we have drawn already lah. The forces acting. Okay, forces acting. Okay,
Uh, yeah, I mean it's okay lah, but it's not very straightforward, teacher.
not very straightforward because you are new you are new to the
Oh,
is you are new to the equation. Okay, where is the string likely to break? Describe the path of the mass when the string break. Yep,
string will break at the.
where will it likely to break?
You mean while spinning, is it?
Say again.
While spinning.
Yeah, when we're moving in a circular path, it will break where the tension is the largest. So if there is some problem with the string,
Oh yeah.
I'm just reviewing with you what I teach you. That's all. Nothing new.
Okay.
Yep, where it's likely to break. Break at the lowest point, where the tension is the largest. Right? The mass will move in a parabolic path. Break it, no force already, only gravity pulling it. So it moves in a parabolic path to the ground and stop a short distance away due to friction. Okay,
Yeah.
this one came out during when I was your age lah. Now I haven't come out already.
Oh, teacher, you took A levels?
No, last time was called HSC. Last time we got no tuition. So if teacher is bad, you also have to you have a problem. Lor. So that's why my physics is not that good. Lor. So you have
Huh?
my physics is not that good. All I've learned, the physics I've learned is because I have to force to teach you all. To teach a student in A
Oh.
level. So that's where I learned my physics.
So how long have you been teaching physics already?
Say again,
How long have you been teaching physics?
from 1990, lor. All the while I've been teaching physics and a bit of maths. Then come to Sunway College, 1990, I teach physics. Lor. So that's where
Also, you only taught at Sunway College, ah.
I teach in different colleges, INTI College, FIT. So when you teach A level, it's more challenging. Lah. So you have to,
Oh.
I'm better in maths, but I have to learn my physics lor, to teach physics. Okay, try this one. I'm forcing you to use formula, that's all, and then to read. Find the speed, lor. You are given period, you are given radius. Find the speed. Speed is
Okay. So
distance over time. Right?
2 pi radius over period. Oh.
in your value, calculate out. Then A is V square over R, put in your value, calculate out. Okay, one last one, then we go to
I
gravitation.
got 4.71.
Which one?
Question 9.
Huh? 4 point,
Yeah, that's
yeah,
three.
correct. 4.7, correct. The velocity is 4.71, correct. Can get the acceleration.
Yeah,
Oh,
formula.
okay, try the last one. This one. The rest you can do it during your break. Remember, next week no class.
So it's 2 pi over 1 day, isn't it?
One day given you the period is given you
Yeah,
just 2 pi over the period, correct? You're right. Okay. Linear speed,
2 pi over the period, I got like very, very small value.
V equals R omega. Lo.
It's 7.31 times 10 to the power of negative 5.
Very small value, omega. Right? Linear speed, can
Yeah,
468 meter per second. Then the acceleration should be able to get 3.4 times 10 to the power minus 2. Okay. As I said, the rest you can do during the break to reinforce the formula. It's okay. You are quite new today. So you are learning something new. So it will take a while for it to digest.
okay.
Okay.
So what's the difference between period and time?
Time is general. Period, it move one round. Lo.
Oh, so period is the time taken to complete one cycle.
Cycle or one revolution. Lo.
Oh, okay.
Anything else you want to ask before we go to topic 13?
So fast,
Finish already. Finish already.
My teacher, then that means this is the easiest chapter in A2, is it?
A2 is more challenging.
But I think chapter 12 was quite easy.
Chapter 12, they simplify it. Lah. That's why it's a bit easier. But as you go further, it's become more challenging. Lah.
Is there harder questions in chapter 12?
Chapter 12 usually just a formula memorized as well.
Oh,
They
okay.
they don't set it separately. Very few they set separately. They usually will test you under gravitation. So
Oh, then which chapter is harder?
all the topics are harder and harder. Lo. Depend on
I mean
whether
in
you
A2.
like it or not. Gravitation field is also quite hard, quite challenging.
Oh, okay.
Okay. If okay, I start.
Hmm.
AS is still easier. That's why you have to score as high as possible AS so that it will bring your grade. You get a better grade because each of them is 50% AS and A2.
Yeah.
Okay, we will define, just give you a bird's eye view before we go into the topic. gravitational field strength, right? That's our definition. F over m, right? Is actually the weight or the gravitational force. And m is the mass you place in the field. Then we will derive the formula gravitational field strength around a uniform sphere, right? 4 pi r squared. R is the radius of the sphere or distance from the center of the sphere. Gravitational field strength or acceleration due to gravity, same thing. Force between point charges, right? Newton's law of universal gravitation. Right? As I say, draw your own mind map to summarize what you have learned. Then you can memorize it, review it. Right? We call point mass when the distance between the two mass is greater than the size. Right? F is the gravitational force. Motion of satellite, that is where the application will be for circular motion. Centripetal force equals gravitational force. So we will derive the formula V squared over Gm, quite popular topic. And then V equals to 2 pi r over T. And now to derive T squared is proportional to R cubed. And we introduce the idea of geostationary orbit. Gravitational potential, a bit more challenging. Right? That's the definition. There's a formula. Around a uniform sphere, distance r away, mass of sphere is m, and gravitational potential energy, if you like, at the distance r above the Earth's surface, r from the center of the Earth. Right? Escape velocity, normal in the syllabus. Okay, that's your data. Right? Know where to find your gravitational field constant, G, capital G, acceleration due to gravity, and then formula given, gravitational potential given, gravitational potential energy. Okay, a sphere of uniform density. It's a sphere of uniform density. Right? There's a point, a distance out from the center. So we can assume that the mass of the sphere is concentrated at the center. And then we can use a calculation. C is the center of the circle. Right? That's what your syllabus require you to assume. Instead of thinking of it as a big mass, think of it as a mass at the center, a point mass at the center. And then there's a force on the mass M. Right? Distance is still the same, R. What's the field of force? Memorize. A field of force or force field is a region. Field is region of space where a particle placed there experience a force. Right? A particle that placed there experience a force. Example, gravitational field, a mass experience a force. Right? Anywhere you stand, you experience a gravitational field. How do we know there's a gravitational field? We take a mass there, drop it, let it go, it will move down to the surface because there's a force on the mass. Right? We will study electric field also. Same. Right? Electric field is a charge, experience a force. Whereas a magnetic field, a tiny magnet or current carrying conductor placed in the field experience a force. Right? You will study in A2 all this. Okay, gravitational field. Right? It's just a region that the Earth gravitate. The region around the Earth is the gravitational field. Any body, right, or any object creates a gravitational field around itself. So you, around you, you have a gravitational field around you. Around the Earth, the gravitational field. Right? Field is a region of space where a test mass experiences a force. Right? You take a mass there, place in the field, you experience a force. Because the field around you is very small. So you will not, a mass there near your body will not experience a force at all. Because the Earth field is stronger. Around the Earth is the gravitational field. Gravitational field is the force field. So you have a mass there, we call test mass. Place in the field, experience a force. Don't worry too much about test mass. The idea of test mass is the mass is very small. You place the field, it doesn't affect the field. The mass is so small, it does not disturb the field at all. Right? Just a mass placed above the field, it will accelerate towards the surface. How do we represent the field? Right? Uniform sphere or the Earth, center C, region around the body is the gravitational field. We represent the field by line of force. A line of force in a gravitational field is a tangent to the curve. At Cambridge, instead of calling it a curve, you would call it a line. So it means the same thing. Give the direction of force on the small test mass. Right? Here you won't see the curve. It's more of a straight line for gravitational field. Line of force give us the direction of force on the mass. So basically it tells us the force on the mass or the direction the mass will accelerate. That's a line of force, all pointing towards the center of the Earth. The arrow on the field lines show direction of gravitational force on the mass placed in the field. Right? It shows us the line basically tells us that put a mass at any point on the line, it will move in that along the line to the surface of the Earth. So where the field is stronger, where the field is closer, same like electric uh, electric field, stronger, the line are closer. Weaker, further away, where the lines are further apart. Right? Or we usually think of it as number of lines per unit area. No? Closer to the surface, more lines per unit area, and further away. The spacing of the field indicates the strength of the gravitational field. For weaker field, the lines are far apart, and for stronger field, the lines are closer. Okay? That's why the surface there is closer, the lines are closer, farther apart, weak field. Now you got 10 more minutes. The field around a body is non-uniform. Non-uniform. Uniform must be parallel. Non-uniform, this is non-uniform. Right? It has the same magnitude, but direction is different. A mass of sphere is concentrated at the center. So the mass is concentrated at the center so that the lines appear to converge to the center. Right? Represent the uniform sphere. That's the center there. So the line behave as if it's moving towards the center of the sphere. Gravitational field near the surface of the Earth. Near the surface of the Earth, about 2 kilometers above, the gravitational field is uniform. That means they are parallel. That's within the region, the gravitational field has the same value, always pointing towards the surface. Here, the lines of force are parallel and equal distance apart. That's all. Equal distance, parallel. That show you uniform. Define gravitational field strength. Force per unit mass on a test mass placed in the field. F is the force acting on the test mass M. Unit is Newton per kilogram. Right? F is the force acting on this mass. Right? To find the gravitational field strength, we take a mass, find the force on the mass, and divide force divided by mass. Memorize the formula, know how to use it. Right? Force is in Newton, mass is in kilogram. So Newton per kilogram. Any comments so far? Or anything you want to ask?
No, don't have.
Okay, that's how you show uniform field. Parallel line, equal distance apart. Right? Gravitational field strength. The vector quantity. Right? Unit Newton per kilogram. Direction. Direction of acceleration of a small mass placed in the field. Right? So direction of acceleration or direction of the force on the mass placed there. Right? This is a test mass. It will accelerate downwards there. So that's the direction of the field lines. Also known as acceleration due to gravity. Right? So near the Earth's surface is 9.81 Newton per kilogram. Right? That one we have gone into that. Gravitational force between point masses. Understand that for point outside a uniform sphere, the mass of the sphere may be considered to be at a point mass at its center. That's the syllabus. Newton's law of gravitation. Right? There's your mass M. There's your mass capital M. The distance between the mass is R from center to center. So the force of gravitation attraction between two point masses is directly proportional to the product of the masses, multiply the mass, and inversely proportional to the square of the distance apart. Right? From that statement, you should be able to write the equation. Point mass, condition for point mass, your distance is greater than the diameter of the mass. Okay, very much the distance between the mass is very much greater than the diameter or size of the mass. That then you consider as a point mass. Right? The force is attractive, action and reaction force. Right? That's the equation. G over R squared. Memorize. Is this a point mass? The 2%?
Mm, I think so.
No, they are not point mass. When you and I become point mass,
Oh,
when you and I become a point mass,
are you asking me a question?
where you see me as a point, I see you as a point, no? That means you are very far away, no?
Oh,
That's what I mean by point mass. Right? That means the two persons must be very far away from each other. The further the better. Then they look at each other becomes something like very tiny, like a point mass. Right? This approximate already lah when they part. Okay, so the formula or the law works for point mass. Right? That's it. When the spherical mass are of uniform density, or the two mass are of uniform density. R distance between the center of the point mass, G is a universal gravitational constant, 6.67 times 10 to the power minus 11, given in the data sheet. M1 and M2 mass of point mass. Force on M1 is equal but opposite to force on M2. That's Newton's third law. Action and reaction forces. Force is attractive. F1 and F2 are action and reaction forces. It's known as an inverse square law, right? Because of the R square. Right? This is for your information. We can determine G by using Galvanic balance for info only lah. Don't need to worry about that. Okay, that's how we find that. What is meant by point masses? We are just repeating. Right? When the separation R is very much greater than the size of the object. Newton's third law of motion. The Earth pulls on the moon pulls back on the Earth. Right? See, the force is magnitude the same, direction different, that's all. With a gravitational force. So that is how the force varies at the radius of the Earth. Right? That's the maximum. After that, it goes down to 0 at infinity. Circular orbit in inverse square law field. Example, satellite orbiting the Earth. Satellite can be moon, natural, or artificial. Earth orbiting the sun, then the Earth becomes satellite of the sun. In this case, the center must be the center of the Earth. Whether it's equatorial orbit, the satellite, motion of satellite, or over the pole. Motion of satellite in circular orbit. Consider a satellite of mass m moving in a circle of orbit radius r around a body of mass m. Right? That's a body of mass m with a speed v, orbit around there, distance apart is r or radius of the circle. Mass of satellite is m. Centripetal force is provided by the gravitational force of the body on a satellite, assuming a body of uniform density. Right? So gravitational force equals centripetal force. That means the gravitational force provides the centripetal force. Cancel the small m. Right? V square over r gm. Right? Very popular derivation that you need to know to derive. Speed of satellite is dependent on the mass of the body. Depend on this mass. Doesn't depend on the mass of the satellite and radius of the orbit. Anytime you will stop now, so I will leave question for you to ask.
Okay. I'll do the next one.
You can show that t square is proportional to 1